I want to talk today about the principles of evolutionary architecture, describe the term and how we came up with the name, some techniques that we've used that actually support an evolutionary architecture, and then give you some idea on how you might actually create an evolutionary architecture for yourself. Why should you care? And hopefully, this is all blindingly obvious to you. The expectations that our customers and our customers' customers have for change, those expectations are changing rapidly, and that pace of change is increasing rapidly. And so we have to be able to respond. Business model lifetimes are actually shortening. So it used to be you could be dominant in your industry and work on effectively the same business model for decades. We're down to years, if not multiple months at this point. And it's harder to predict the future. I've been doing this for a long time. I've got all kinds of gray hair to show for it. You could probably think about a 5 or a 10-year roadmap when I started in this business. You can't think about a 5-year roadmap now. It's just going to change too rapidly. Think about the fact that the iPhone was introduced just over 10 years ago. So when journalists ask me, tell me what the technology landscape will look like in 10 years, I laugh at them because I don't know. And there's no point in me actually trying to guess. What constitutes a good architecture changes based on the organization, based on the system, based on the domain. When you are talking about architecture, there is no single definition of what constitutes good. So borrowing the term from evolutionary computation, we're going to specify an architectural fitness function. We are going to decide for our system what constitutes good. And that fitness function is what we use to guide the decision making for our architectural decisions, our technology choices, because we want to move in that direction. And so we call it evolutionary architecture, inspired by evolutionary computation. We draw a lot, in particular, from genetic algorithms, genetic programming, which explicitly have a fitness function. There are two aspects to incremental change that we talk about. And the first is, how do you actually get change into production? We've learned a lot from how Netflix works. We've learned a lot from the DevOps revolution about how to be able to adapt your architecture to more safely deliver things into production. Continuous delivery is a big thing that enables this. And then there's also how do we incorporate this into the software delivery lifecycle? Deployment pipelines, again, are very important, because what good is defining these fitness functions if we never test our system against them? And what we want to do is we actually want to incorporate the analysis of these fitness functions, whether they be simple things like a cyclomatic complexity check, something more complicated like consumer-driven contracts, or something really comprehensive like the chaos monkey. We need to make sure we have a place to run these things, and a deployment pipeline is a perfect platform to allow us to execute these fitness functions, which then allow us to monitor whether or not our architecture is respecting the characteristics that we wanted it to. But another important aspect of this multiple dimensions is, as architects, one of our most common words is trade-offs, because you can't maximize all of these things. If I increase security, I'm going to decrease performance because of additional abstraction layers for secrets hiding or additional encryption. So I can't maximize both of those. That doesn't mean I can't have acceptable levels of both of them, but I can't maximize everything. So I have to decide, for these different characteristics, how will I make the trade-off? How might I trade off a caching strategy to increase performance versus a data staleness requirement for security? So we need to think not just about these dimensions as isolation, but how they relate to each other. I want to talk about some principles that underlie evolutionary architecture. Last responsible moment, both architect and develop for evolvability, this new meta characteristic. We'll talk about Postel's law and what it means for communication. Architecting for testability. I'm from Thoughtworks, we have to say testing somewhere. And Conway's law. It's amazing, you get a group of architects together And in my recent experience, it never takes more than 15 minutes for somebody to bring up Conway's Law. So let's start with the last responsible moment. Basically, what this means is you want to delay your decisions as long as possible, but no longer. Seems pretty obvious, because it maximizes the amount of information you have to make a decision. And it also minimizes the amount of technical debt from complexity that you introduce. When you think about how many architects in large organizations work, they find the most complicated messaging problem, and they pick their messaging infrastructure to solve that problem. And so all of the other ones that have a much simpler problem have to use this incredibly complex tool. That is a form of technical debt. Because every time you're doing something with that messaging infrastructure, you're doing more than you have to because of that. Now, I often get asked, okay, well, how do I know what that last responsible moment is? And that's where your fitness functions come in. You've come in and you've had this conversation about what are the key architectural drivers that are going to have the largest impact on your system. And you use that to determine, along with your organizational processes, when I should make particular decisions. Sometimes that decision is made for you. Assuming evolvability is something you're worried about, the first thing is how you think about breaking up functionality. You want to think about your systems not from the perspectives of software, but from the perspective of the application. Because if you start to think about functionality in that way, the people who are giving you requirements, they're going to be thinking about the problem from the domain. And it's going to more likely be easier for you to accommodate that if your units of functionality map roughly to how the business actually functions. This is just using domain-driven design conceptually, DDD with small letters, not necessarily the entire process, but think about what your unit of functionality is, because that's going to give you that flexibility to move things around. People very often don't think about data ownership. When you're architecting a system, if you think about those things, you can, again, partition things in such a way that it will make it easier to evolve along the data aspect. And appropriate coupling. Some things need to be tightly coupled, but you want to think about your coupling strategy. Why are things tightly coupled? And accept that perhaps you were making one of those trade-offs. You're decreasing your flexibility a little bit because you need something perhaps performance. And this isn't just because we like Agile. The lighter weight something is, the easier it is to use. So if you can get away with using a lightweight tool, do so, because it will be less drag on your development. Software internal quality matters. You cannot change something if you cannot understand it. If it is an ugly mess, you cannot understand it. So you want to focus your metrics on ease of change, and that means it's easy to understand, it's easy to read. Now, if you're dealing with an existing system, what do? I used to be a university professor. I would love to say no dirty code should ever exist anywhere on the planet. Unfortunately, that's not practical. So if you're starting from a mess, find your hot spots. Think about where people are most worried when they start talking about having to change a part of the system. When do your operations folks get nervous? Oh, did you hear? They're deploying a new version of this. We better cancel all of our holidays. People know where those vulnerabilities are. Look at your defect log. Look at your check-in log. See where there's activity. Now, what about communication? Pastel's law. Be conservative in what you send. The minute you put something out, whether it be in a database, on the wire, somebody now believes that you are going to continue to do that. You've made a contract with them whether you know it or not. And so you want to be very conservative in what you send, but you want to be very forgiving in what you receive. Now, asterisk, of course, make sure you've got the right kinds of checks in there so you're not opening up a security hole. But if all you care about is the postcode, don't validate the entire address. Because if they want to change the format of the rest of the address and you're validating it even though you don't need it, you're going to have to change when you really don't have to. And this holds for any information exchange. People often don't think about this in the context of databases. Architect for testability. One of the things that we have actually found is if you aim towards a testable architecture, you will tend to have an architecture that is easier to change, because it steers you away from things that are bad ideas, like using the messaging infrastructure for too much business logic, because those middleware vendors still really haven't figured out how you do the kinds of automated testing that we would like to do. It also drives you more towards these business sensible components, because if you're thinking about acceptance tests, you're going to want to think about names that make sense to the business. We had one of our customers, a medium-sized business, not small, but not massive. The CEO of that business, every single month, read through the acceptance tests. And he said, the reason I do this is because that way I know what my product does. I don't have to rely on my marketing people telling me what they would like my product to do. I know what my product actually does. The reason he could do that is because the acceptance tests were written in his language. When I first started talking about evolutionary architecture, people would come up very quietly at the end of the talk and they would say, don't you think you're being professionally irresponsible advocating for evolving an architecture? I mean, architectures, that's the foundation, that's the rock, that's the stability. How can you talk about something as radical as evolving an architecture? Well, it is radical and it is dangerous if you don't have the right kind of testing infrastructure in place. You do need to know that you've got the right kind of testing safety net to understand the implications of the changes that you are making, which means you're going to need a build pipeline to support this. Otherwise, it just really does not scale. There are people problems that we can deal with. And Conway's law essentially says the design of an organization, and in particular its communication patterns, is going to influence the software that that organization creates. And broken communication implies broken integration. One of the ways I look really smart when I go to some of our clients is I just watch the tech leads for different parts of the system. And if they talk to each other, if maybe they sit at the same lunch table, if they at least say hello to each other, probably the integration is not in too bad shape. If you find them walking past each other like that, that one's broken. And silos often result in this broken communication. No one would ever assume I'm a project manager or an organizational design specialist, but I've been in places that even I know the organization is broken. One such organization, to deploy any change whatsoever, required the coordination between all 7 different development teams. That's just wrong. And these teams weren't even in the same country. So you need to think about how you're breaking things up. Because if you don't, you're going to have all kinds of dependencies that are going to make it very difficult for you to respond to the changes that are occurring. And of course, if you don't want your product to look like your organization, you have to change your organization. There is no choice. You can try as much as you want, but you cannot defeat Conway's law. Okay, so some techniques. Database refactoring, continuous delivery, choreography, and contract testing. Each of these talks about some aspect of how you can make an architecture more evolvable and keep it evolvable. And probably the single most important enabler for this is database refactoring. And there's a book that was written just over 10 years ago called Refactoring Databases. And its subtitle was Evolutionary Database Design. You need to read this book. If you do not have the ability to change your data, you are not going to be able to evolve your architecture. And I actually think of all the people who complained about agile software delivery, the people who had the biggest reason were the DBAs. for a single reason: data migration. Data migration is hard. It doesn't have to be. It doesn't sound like it should be, but it's hard. So what this book talks about is how you can make even large-scale changes. It's focused on relational databases. The concepts apply to NoSQL databases as well. It's just the individual refactorings and patterns are different. But you want to decompose your change into atomic changes. And each one of these changes is a triple, which includes the change to the database. What's the migration you have to do to take the existing data from the old into the new just for that one piece of the change? And then any changes you have to make to the access code. And then you compose them in the same way you compose these things. Version control the changes and apply this during promotion. So what this does, just like how we hammer on about continuous integration and how if you decrease the scale of your individual changes, when something goes wrong, it's much easier to figure it out because you've only changed a few methods. When you have those little fields back from August 14th, 1964 to August 18th, 1965, it meant something different. And it always breaks the migrations. And everybody always forgets that they have to do something with all those little breadcrumbs or skeletons that are scattered. By breaking this up, you find those things not on the wholesale change and all of them at once, but you find the subset of records that are affected by one particular change, and you can fix that and then go on to the next one and go on to the next one. Continuous delivery. I told you that people for a while were calling me irresponsible for talking about this radical notion of evolutionary architecture. But I will say that the disciplines that come from effectively implementing continuous delivery make this much less risky. The important things about continuous delivery is you're automating basically all the things. And what happens when you automate things is they always happen in the same way. Unless you've got some inherent non-determinism, every time you run it, it's going to happen the same way. And deployments should be boring. You should be celebrating the features, not the fact that you didn't get into trouble because it took too long to bring the system back up. That's what continuous delivery is all about. Yes, it also allows you to check in something and have it go all the way into production, but there is nothing in that book that says there's anything wrong with giving a big green button to the CEO and allowing him to hit the button and nothing deploys into production until he hits the button. Just because you can have it flow straight through doesn't mean you have to. But the important part is you can. And if you can, that means that when you deploy, it becomes a business decision, not a technical decision. And when something goes wrong, you know exactly what your environment is. So we're talking about choreography as opposed to orchestration, and this is really around services. So what's the distinction here? With an orchestra, you have a conductor, and everybody is paying attention to the conductor. And I recently found out that there are some pieces where the cadence of the piece is so different that they actually have two conductors. And one part of the orchestra pays attention to one conductor and the other part of the orchestra pays attention to another. But the thing is, if the conductor falls off the stage, eventually things stop because nobody knows what to do. That is a single point of failure. In choreography, think about a dance performance. You have a choreographer who sets the vision, and you have scripted outcomes, and every individual knows what they are supposed to do to move that vision along. And in a dance performance, the choreographer is not on the stage. The choreographer is back in the background, and each of the performers is performing independently based on what they know, including what happens when something goes wrong. So I'm getting ready to leap, and I'm supposed to be caught by someone who falls. Well, I probably don't want to leap if he's on the ground. But I know that part of the reason for the leap is I'm supposed to eventually end up over here. So I try to be graceful and not trip over him and walk over there. I'm responding to the actual environment as opposed to saying, excuse me, choreographer, what am I supposed to do now? You're individually responding to what happens, which means you're distributing the authority to the individual actors. You no longer have someone who's moving all the pieces around. That responsibility is distributed. The good news is that makes it easy to move those pieces around because you have local interactions that you're worried about. The problem is, this is true of microservices architectures, for example, you're introducing all kinds of failure modes that could never have happened before. There are some things that simply can't go wrong in that way with a monolith. And so you have to decide, is this increase in the flexibility worth the cost of dealing with all of these failure scenarios? In some cases, it might be. In some cases, it's not. Contract testing. Essentially, this is a fitness function that looks at the interaction between different parts of the system. And it's an acceptance test. And what it's actually doing is documenting the assumptions that these different aspects of the system are making of each other. And what this does is it maximizes the amount of work that can happen independently. So Tom and Scott and Suzanne all use my service. And we give each other tests that document the assumptions that we're making of each other. And then we cheerfully ignore each other. Don't talk to them. Have no idea what they're doing. They have no idea what I'm doing. And that's fine until one of those tests break. And now I have to go talk to Scott because this test broke. And what that means is I want to make a change that is impacting the assumption that he is making of me. I don't have to talk to Tom and Suzanne. I just have to talk to Scott. And he and I sort out our differences. We got our tests running again. And then we all go back to cheerfully ignoring each other. And Tom and Suzanne never had to know anything about the conversation because whatever changes I have made didn't impact them. In fact, documenting these assumptions is one of the very valuable roles that some of the best enterprise architects I've known have played in their organization because they understood the assumptions these different systems were making of each other. They were the only ones that really knew what happened when you tried to change the way those two systems worked with each other. By pulling that information out, we maximize the parallel work, and we also make it easier for us to start getting rid of some of those skeletons in our architectures, and we all have them. Think about this in conjunction with Pasto's law. Again, try to minimize the amount of interaction that we actually have to have. We can't make it go away. There's a reason that they're calling my service. I'm doing something for them. But you want to minimize what they know and what we know about what everybody else is doing and limit it only to what is essential. As I said, traditional role of an enterprise architect. Now, when you think about evolutionary architecture, it's one thing to think about it from a startup perspective, where you've got a green field. But what happens if you're dealing with a legacy system? How do I actually get started? I've got a system. I've got messy, messy code that nobody really wants to look at. And I've got systems coupled in a particular way that maybe I don't like. You still want to start at the same place, though. You want to start at defining your architectural fitness function. You want to start picking some of these dimensions of architecture where you feel most exposed. Not most exposed to a particular kind of change, because you can't predict that change. But where do you think you're furthest away from what you would want to be? An engineer at Netflix never worries about having a misconfigured RESTful endpoint because of the doctor monkey. It monitors everything in production. And if it finds a misconfigured endpoint, it throws it out. So another one of those functions that used to be governance, you never have to worry about because it's automated. So think about what are the characteristics that are missing in your system, figure out a way to look for it, put it as something like the Simian Army running in production, put it into your build, and start to make progress on all the aspects of your system that you don't like. Delay your decisions as long as possible. This is a hard one organizationally. People in procurement, their job is to make buying things difficult. Enterprise architects in the past have felt that their job was specifying a particular tech stack. So there are definitely some organizational implications for having to work in this way that you want to think about. We often think about technical debt just from the perspective of ugly code. People like Gartner also talk about technical debt when you think about you haven't upgraded a framework and how long will it really take for you to actually get up to the current version of SAP or the current version of your database. But there is also the technical debt that comes in as drag because you're actually not using the right tool for the job. So that is one aspect of technical debt, and you want to think about where that debt comes from. Evidence-based reuse. The number of architects that I've talked to who even are still thinking about, I can sit in my little room and I can come up with reusable components. I've known architects that were actually, their performance evaluation was based on the amount of reuse of components that they dreamed up sitting in their little office all by themselves. That is not going to end well. Part of what we're advocating here is you actually want to know something's going to be reusable. So think about this. And a lot of what this requires is a lot more communication amongst the teams. And you want to change your interaction between the development teams and the architecture teams. As I said, a lot of what we're trying to do with this is automate governance so that architects can spend time doing useful work. So maybe they can go and talk to more of the teams and find out what they're actually seeing. Maybe there's a situation where we have a disconnect between a security objective and a performance objective, and the teams can't figure out how to meet both at the same time. Bring in your expensive architect to help solve the problem, help figure out, is there a way that we can get both of these objectives met simultaneously? Or do we have to start thinking about backing off one of those requirements, and if so, what are the implications? We want to make sure that we know what the expected behavior is of the system at all of these different levels. And as I said before, you can think of things like the deployment pipeline as a platform. What we're trying to do here is talk about what are the things that make systems hard to change, and so we can systematically tackle that. Data is a big one. Refactoring databases. Not actually knowing what it takes to get something into production is a big one. Continuous delivery. Knowing that you can safely deliver and therefore safely experiment. Having a basic understanding of the architectural integrity. One of the things that very often happens, even with the best of intentions, you design a system to exhibit particular characteristics, and then the real world comes in. Maybe it's a regulatory change. Maybe it's schedule pressure. Maybe it's you hired a whole bunch of junior developers that are still learning how to do some things. And your code and that system starts to wander. And in the past, when we've looked at architectural characteristics, it's tested in the performance and technical test cycle. We might do some of these things occasionally. What we're advocating here, And what is supported with things like the deployment pipelines and the testing safety net is you are continually monitoring all the aspects of your architecture that you decided were important. If it's not important to you, you shouldn't have a test in there for it. Anything you have a test in, just like other test suites, you need to maintain it just like you maintain code. It is part of the asset of the system, but with this, you can have an evolutionary architecture which will allow you to respond to the changes that actually happen in your ecosystem, not in the ones that you would like to have happen. Thank you very much.